In part one of this lesson series, we did a quick recap of learning and memory. And we said that when we learn something, there are changes happening in the hippocampus. So synaptic plasticity is, in a sense, making a memory trace of that episode. But over time, the memory is transformed in a way that the cortex becomes more significant for retrieval. And we call this process consolidation. In this lesson, we'll take a look at the research of Robert Bjork. And this body of research will help us think about best practices when it comes to our study strategies. First, he asks us to consider some common knowledge out there in the world, that learning is the storage of information and forgetting is when that information decays. And that seems reasonable as a first sort of crack at understanding what is it to forget something. Well, maybe we have lost the actual information. The information has decayed. But he's going to ask us to reconceptualize this, that this is inaccurate. And we have to have a good understanding of learning and memory and forgetting if we're going to craft best practices in our study approach. So here are two important concepts that he asks us to think about. That memory representations are indexed by two strengths, storage strength and retrieval strength. Now, storage strength indexes the learning, and once accumulated is never lost, and it reflects how interassociated a given representation is with other memory representations. And we talked about semantic memory in a previous lesson, so how well integrated a piece of information is with other things we already know. If it's well integrated and strongly linked to other things, it would have high storage strength. Retrieval strength would be the current ease of access to the information, how primed or active an item's representation is as a consequence of recency, we've just been thinking about it or accessing it, or current cues. The cues are sufficiently powerful to quickly reactivate the information. And the retrieval strength completely determines the probability of recall. So if we're forgetting something, if we cannot remember something, then we have a loss of the retrieval strength. Now, to get a sense of what kinds of things sort of would have high and low storage strength or retrieval strength, consider this box here. Let's take the first box up here, top left corner here. This item would have high storage strength and high retrieval strength. What would it be? Your address or your phone number. It is well learned. You've stored it strongly in your memory system, and you can quickly access it, so it has high retrieval strength. By contrast, your old address or your phone number would have had high storage strength as well, but because you haven't used it in a while, it has low retrieval strength. But notice, if somebody reminds you of it, or you look it up, it quickly comes back to mind, and then you will have high retrieval strength again. So it had high storage strength, but because you didn't think about it for a while, you lost retrieval strength. And when you get reacquainted with that number, you can get to a point where you have high retrieval strength again. Now, on the other side here, something with low storage strength, you just learned a new phone number of your friend, let's say, but because you just learned it, it has high retrieval strength. But still, it has not been well integrated into your long-term memory system. And then the low condition would be all the kind of stuff that we learned during the day and then forget. It never does get high storage strength. We never really learn it well, and we easily forget that stuff. So Bjork and his colleagues are going to ask us to reconceptualize the process of forgetting, for example. First, we have to remember there are two processes, storage strength and retrieval strength. And disuse does not lead to a decay in the storage strength of the material. So it's not that the memory is somehow degrading over time. Rather, disuse causes a decrease in retrieval strength, the current accessibility of the information. So forgetting is a loss of access. It's not a loss of the memory, it's a loss of access to the memory. Now in this slide we see an interesting relationship then between storage strength and the rate of loss of retrieval strength. So as an item of information has higher and higher storage strength, then the rate of loss of the retrieval strength goes down. Another way of thinking about the rate of loss of retrieval strength would be the rate of forgetting. So in other words, as an item is more and more strongly stored in our memory system, then the rate of forgetting will be low. If it's not well stored, then the rate of forgetting will be high. So, of course, if we want to be lifelong learners and we want to learn things, we want to store information in a strong way so that we don't forget that information. When we store information strongly, we will forget it less quickly. If we don't make a strong storage of the information, we will quickly forget it. Now, let's try to connect up these two terms with our understanding of sort of the memory processing in a brain. Here we have the working memory system, and what is in working memory has the potential to enter long-term memory system through the hippocampal system, and then consolidation processes making a strong cortical memory of the information. So retrieval strength is a measure of the ease or speed with which information can be retrieved. It's associated with how efficiently the working memory system can search and retrieve information from either recently active working memory, so the working memory boost, or the long-term memory system. If we have stored something very strongly in the long-term memory system and we have the right cue, we can quickly bring up that information, so that would be high retrieval strength. The storage strength is related to the strength of the memory trace in the cortical memory systems as a consequence of consolidation. Multiple consolidation episodes will increase the storage strength of a memory. So we can think of the retrieval strength as the sort of ease of access to the information, and storage strength is to sort of how well stored, how strongly stored it is in the long-term memory system. Now you'll recall the lessons on the working memory system, that recently activated loops are primed for a short while, making immediately retrieval easier, and we call that the working memory boost. So there are two ways to have high retrieval strength. One is the working memory boost. So anything that we were just recently thinking about, well, it will enjoy the working memory boost because those synapses are temporarily facilitated here, and so it's going to be more easily retrieved. Now, with greater delay, the retrieval is more difficult because those synapses are going to weaken again. So one way to have high retrieval strength is if we were just thinking about something and then we get the working memory boost. And the other way to have high retrieval strength is that the memory is well stored in long-term memory, so it can be quickly accessed with the right cues. And in a previous lesson, we learned about the semantic memory system as sort of concepts that are linked into these networks, and if they are strongly linked and interconnected, then the proper cues can quickly reactivate the relevant information. So high retrieval strength can be due to two things: the working memory boost, or well-stored information and properly cued for recall.